Hi friends, Dr. Lewis here. Today we're going to be working on finding factors. This is going to help us meet this standard, which is 4.OA, Operations and Algebraic Thinking, and it's the fourth one. This standard is going to be turned into 3 learning targets. So we're going to go over those. I'm going to show you some vocabulary and just give you a couple of helpful tips that are going to help you solve today's work, the problems in today's work. Okay, so let's look at our first target. I can find all factor pairs for a whole number from 1 to 100. Now, you probably remember this from the beginning of the year, but if you don't, never fear. We are going to chat about all of those things. So let's break this down. We're looking at the word factor. Okay, what is a factor? You probably are getting some of your memory back from the beginning of the year when we worked with these arrays and we were looking at building arrays using the same number of squares. So for this particular one, all of these arrays form 16, but you can see this is a 4x4 array. This is a 2x8 array, and this is a 1x16 array. So take a second and think, what does that tell us about what a factor is? A factor is a whole number that divides evenly into another number. So using this picture, we have 16 divided by 4 equals 4. So 4 is a factor of 16. If we took 16 divided by 2, that would equal 8, or 16 divided by 8 would equal 2. So 8 and 2 are factors of 16. Same thing here. Look, we have one row of 16 cubes. 16 divided by 16 equals 1, or 16 divided by 1 equals 16. So 1 and 16 are factors of 16. So what I'm going to do is I'm going to write the definition. Factor is a whole number that divides evenly into another number. So for example, we have 16, and all the factors of 16 are, let's start from the smallest one. 1, I'm going to separate it with commas. What's the next one up? 2. 4 is the next one. Then 8. Then 16. So those are the factors of 16. Now, our learning target actually says that we need to find factor pairs. It says find all factor pairs for a whole number from 1 to 100. This is so much simpler than you think, especially if you already know what a factor is. So for example, let's take a second and look at 16. What are the numbers that we pair together to equal 16? Remember our rainbow? We take 1 times 16 equals 16. 2 times 8 equals 16. And 4 times 4 equals 16. So factor pairs are the pairs of whole numbers that can be multiplied to produce a given whole number. Okay? All that means is the numbers that you multiply together to get that number. So for example, 7, the factor pairs that 7 has is just 7 and 1. That's the only factor pair because nothing else multiplies together to equal 7. For 18, it has 3 pairs of factors. 1 times 18, 2 times 9, 3 times 6. These are the factor pairs for 18. And you can see the factor pairs here for 16. 1 times 16, 2 times 8, and 4 times 4. These all equal 16. These are the factor pairs for 16. Nice. Okay, so that covers our first target. I can find all factor pairs for a whole number from 1 to 100. We're going to need to be practicing our multiplication to master that target. Let's look at this next one. I can recognize that a whole number is a multiple of each of its factors. So let's come back to our vocabulary and talk about what a multiple is. Take a look at this image for a second. What do you notice about this image right here that tells you what a multiple might be? So a multiple is pretty much as simple as counting on, skip counting by whatever you're doing. Those are the answers when you skip count. So for example, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. All of these numbers are multiples of 3, because if you counted by threes, 3, 6, 9, 12, and it would go on and on. So the definition of a multiple is pretty long. I'll let you take a second to read that. So a multiple is a number that is the product, or the answer when you multiply, of a given whole number and any other whole number. A number that may be divided by a given number without a remainder. That's really important. For example, 3, 6, and 12 are multiples of 3. So let's think of some multiples. These are the products when you multiply, or skip count. So let's look at 16 for a second. Let's take a number from our factor pairs of 16. Let's take 4. Let's find the multiples of 4. Let's count by 4s. Starting off with 4, then 8, then 12, then 16, then 20, 24, 28. We could literally go on forever because numbers don't ever end. We could be sitting here doing multiples of 4 until my hair turns gray. So what we're going to do is we're going to see how we can meet this target. I can recognize that a whole number is a multiple of each of its factors. So 16, its factor pairs are 4 times 4, 2 times 8, and 1 times 16. We just showed that if we count by 4s, eventually we land at 16. If we count by 2s, will we land at 16? Try it. 2, 4, 6, 8, 10, 12, 14, 16, boom. Is 8 a multiple of 16? Count by 8s. 8, 16, boom. What about 1? Count by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, boom. You nailed it. So multiples are just that. They are the numbers, the products when you multiply. Okay? There's multiples. Okay, now we're going to talk about this third target. This third target, we have to know this information before we can master this target. So I want you to look really carefully at our third pink target. I can determine whether a whole number from 1 to 100 is prime or composite. I bet you've got your memories firing right now, remembering back to the activity that we did where we found numbers, or we decided if numbers were prime or composite. So we're going to define those words right now. So a prime number, look at that visual. I can just see the posters that we made at the beginning of the year using the arrays, why does this only have one array? Well, that's because a prime number is a number with exactly two different factors, itself and 1. So for example, 23. Think of the number 23. Can you divide 23 by anything other than 1? You sure can't, because 23 is a prime number. What are some other numbers between 1 and 100 that you know that can only be divided by the number itself and 1? Well, let's play a little, shall we? So I've got some gems here. Let's count them out. So 2, 4, 6, 7. All right, I'll put these to the side. So I'm going to try to build an array with these 7 gems. So let's see if I can go by 2s. Well, if I go by 2s, then I'm going to have one that's sticking out, and that doesn't make an array. All right, so what if I tried 3s? Again, I've got one sticking out. That doesn't make an array. All right, I can't do 4s or 5s or 6. The only array I can make without having a number sticking out is a row of 1, 2, 3, 4, 5, 6, 7. One row of 7. So because I can only make this shape array, I know that 7 is a prime number. But look, what happens if I add one more? Let's try to make another array out of this one. All right, so I'm just going to bring these down until it makes an array. Let's see. Oh, 1, 2, 3, 4. 1, 2, 3, 4. I've got 2 rows of 4. So that's one set of factor pairs for 2, 4, 6, 8. Let's see if I can do 3. No, I can't do 3. But if I do this, this just gives me a different view of the same one I just did. This is another way to say 2 rows of 4. So I know that because I can make an array other than this array, I know that 8 is not a prime number because it has more than 2 factors. The factors of 8 are, well, 1 and 8, and 2 and 4. 2 rows of 4. So because 8 is not a prime number, 8 is actually a composite number. So a composite number is pretty much the opposite of a prime number. A composite number is a number with more than 2 factors. Okay, so that's a pretty simple definition. Composite, a number with more than 2 factors. So I'm not going to name the factors because it really depends on the number. So for example, we saw that 8, we could multiply 1 times 8 and get 8. We could also multiply 2 times 4 and get 8. So remember, 1, 2, 4, and 8 are the factors of 8 because 1 times 8, that's a factor pair. 2 times 4, that's another factor pair. That means that if I count by ones, 8 will be a multiple. So let's try that. 1, 2, 3, 4, 5, 6, 7, 8. Yep. All right, let's count by 2s. 2, 4, 6, 8. Yep. Let's count by 4s. 4, 8. Yep. Let's count by 8s. 8, yep. So these are the multiples when you skip count. And then these are the factors and the factor pairs. So that information is going to help you determine whether numbers are prime or whether they're composite. Clearly, 8 is a composite number because it has more than 2 factors. It has 1, 8, 2, and 4. We recognize that every factor of 8 is also a multiple of that number. So that information is what's going to help you meet today's targets. So there's 20 questions that you can answer on Illuminate, and then there's extra practice that you can do to help you even more. There's also a ton of videos that you can watch to help you. I hope that you have a wonderful day. I miss you, and I'll talk to you soon. Bye.